So our goal here is to draw a line that corresponds to each one of these. So I want to draw a line that corresponds to this information. Going through the point 3,3 with a slope of 2/3, going through negative 3,3 with a slope of 0, going through negative 1,2 with a slope of negative 3. So let's go ahead and just start this here. The first one I'm going to graph in, let's go with purple here. So how would I graph that line right there? What should I start by doing? Tatiana? Okay. Why this is actually a really important idea. Why do I have to start with the point, and why can I not start with the slope?
You won't know where to
Austin?
But you should start with the slope.
Why do we have to start with the point first and not the slope? Why can we not start with the slope?
I guess because you wouldn't know where your point would, where the other point would be.
Yeah. So the slope tells us what direction a line is going, how steep it is and what direction, but it doesn't tell us anything about where the line is. So unless we have a starting point, the slope is really useless. It doesn't tell us about where to put anything. So we need a starting point, and that's going to be our 3,3. So Tatiana, where is the point 3,3?
Well, you gotta go 3 to the right,
Uh-huh.
and then go up 3. Yeah,
To the up,
3.
right?
Yeah, to the up.
Okay.
I was
So
thinking hard about it.
So we start at the origin, we go right 3, and we go up 3, and we get the point 3,3. All right, now this one's a little bit tricky because a slope of 2/3 tells me that we have a rise, and I'll write this in here. A rise is going to be 2, and our run is going to be 3. Well, a rise of 2 tells me to go which way? Up 2, and a run of 3 tells me to go right 3, and I get a point somewhere over there, and I don't know where it is. It's not a good practice to add lines to a graph. Okay, we ran out of space going up and to the right, so we can't go that way. I do know, however, that the point's going to be somewhere up here, so instead of going up and to the right, what could I do?
Down to the left.
Down and to the left. We could go the opposite. And really what we're doing is we're just saying the slope is negative 2 over negative 3. Why is that the same thing? Two negatives make a positive. Negative 2 divided by negative 3 is the same thing as positive 2 divided by positive 3. So starting at that starting point at 3,3, we're going to go down 2 and left 3. And we can confirm that we did that correctly by starting here and going up 2 and right 3, and we get a slope of 2/3. So we've got our 2 points. 2 points in Euclidean geometry, and now also in analytic geometry, is enough to determine a line. So I can draw a line through those 2 points. So we're going to get something that looks something like that. And I do want these to be lines, not just line segments. So not only should we go beyond the points, but we also want to add arrows to the ends of the lines to show that they go on forever. Notice also, I didn't plot this point, but my line is going through this point. Why should my line go through that point? This point right here. Even though I didn't plot that one, why should it go through that one? Maya? Don't know? Okay.
Shouldn't it be the same distance from like that?
Yeah. If we repeat the slope, so to get this point we went down 2 and left 3, we should be able to do that as many times as we want. So if we go down 2 and left 3, we get another point that's on the line. In fact, some of you last year probably had algebra teachers that said you should have 3 points. Well, I'm not going to say you need 3 points because that's not accurate. You really only need 2 points. But you need to be aware of where those other points are going to be and be sure that you hit those other points, even though you're not plotting them. Does that make sense? Because 2 points is really enough to determine a line, but we want to be sure that we're accurate with it. So even though we're just using those 2 points, try to hit the other points that you're not plotting. Okay, moving on. Let's do this one. Let's start with the point negative 3,3. Where's that going to be, Raven?
Start from 0 and go back. Go left 3.
Okay, so we're going to start at the origin, go left 3,
And then up.
and then up 3, and we get our point right there. Okay, so there's negative 3,3. There are 2 ways to approach it from here with the slope. I'm going to do it the more lengthy way first, and then we'll talk about why that's not necessary. Let's say I want to do a rise and run. Does that mean my rise and run are both going to be 0 here? No. What could I do if it's a whole number so that I get a rise and a run? Put it over 1. Any number is the same thing as that number over 1. So 0 is the same thing as 0 over 1. Negative 3 is the same thing as negative 3 over 1. We're going to have to do that in the next problem. So we have a rise and a run. So starting at this point, how far am I going to rise? 0. I'm not going to. How far am I going to run? 1. So that's going to the right one, right? So I end up with another point right there. And then what does my line look like? My favorite is when I get people that draw lines like this. Well, hey, it's going through both points, right? That's exactly what I was talking about on the other one, though. You want to make sure that it doesn't just go through the points, but it's also accurate. So that's not a good line. It is going to be a horizontal line. Now, how could we have figured that out without using the rise and the run here? Let's go back to where we were right after we plotted the point. What could I do here? I can draw the line right now. Why? What's the slope? What's the slope?
0.
It's 0. What do we know about lines with a slope of 0? They're horizontal lines. So if we have a line with a slope of 0, we know it's a horizontal line, so that point is enough to just draw the horizontal line through it. And that's all we need. We know enough about slopes, about horizontal lines and slopes of 0, that we don't need that rise and run to get that. It's okay if you do. There's nothing wrong with doing it. But this way is just a little bit quicker. Right? All right, last one. Let's see. Is this going to show up on there? Yeah, it's not bad. All right, so we want to do this line now. Where's the point negative 1, 2? Jamie? Okay, so we'll start at the origin, go left 1, and then up 2, and we get that point right there. Okay? And then what do I need to do with the slope so I can get a rise and run here? Yeah, we want that to be negative 3 over 1. So if the rise is negative 3, I'm going to start here. Which way do I go? Down 3, and then to the right 1. If we forget that 1 on the bottom, what we end up with is a point that's right here, and that's going to be a vertical line, and it's going to have undefined slope, and it's totally not what we want. So you want to be careful about that. Let's see, line's going to look like that. And that's a fun looking arrow. Any questions? Comments? We're going to talk later about what it means to define a line. So let me just kind of introduce that idea here before we get going. Just like I did up there. Sorry. I needed to give a little help there. So I'm going to ask the question, how much information do we need to define a line? And here's what I mean by define a line. How many lines are there with this information that are different? So how many lines are there that go through the point negative 1, 2 and have a slope of negative 3? There's just one. This line right here is the only line that has that property, or those properties. How many lines are there that go through the point 3, 3 with a slope of 2/3? Just one. Just this one right here. So this information right here defines a line. It defines a line because it tells us enough information about that line that we know exactly where it is. There's no ambiguity. There's nowhere else it could be. It's that line right there. So when I say we want to define a line, What I mean is, you want to give enough information so that somebody else, anybody else, can take that information and know exactly what line you're talking about. Okay, and we're going to talk about a couple of different ways to do that. In fact, we're going to talk about that here, kind of. Let's say that the only 3 lines in the world are these 3 lines right here. These are the only 3 lines that exist. Okay? Now, I want you to pick one of those 3 lines. Okay, I don't want you to tell me which line. And I want you to describe that line to the class, or I might pick on you to do this at least, using only the slope. So basically what you have to do is pick a line and then figure out what the slope is. Do that right now. Pick a line and then figure out what the slope is. Kayla, what's the slope of the line that you chose? 2-1? Like the point 2-1?
Oh.
Like the point right here at 2-1?
Or 21.
I think she means 2 over 1. Do you mean 2 over 1? Or 2 over 1? Okay. Or just 2, right? Okay, so Kayla picked the line with a slope of 2. How many people think they know which line Kayla picked? Really? Kayla picked the line with a slope of 2, or 2 over 1. How many people think they know which line she picked? Which one did she pick? The blue line, right? Because that has a slope of 2 over 1. Okay, who picked a different line? Austin, what's the slope of the line you picked?
Wait, what was it? 2 negative 3.
2 minus 3?
Yeah. 2 combination.
How about negative 2/3?
Negative 2.
Slope is a fraction, not an order of pair.
Oh.
Okay, so Austin picked the line with the slope of negative 2/3. How many people think they know which line he picked? Shout it out. Hey guys, let's focus please. How many people think they know which line Austin picked with a slope of negative 2/3? Tatiana, which line did he pick?
What do you say again?
Negative 2/3.
I'm gonna go.
The green line. Okay, so in this case, with this set of lines, the slope is enough to define the line, isn't it?
Yeah.
So if I tell you the slope, you know which line I'm talking about. So slope is useful here, but it's only useful here because all 3 slopes are, say that louder, different. So all 3 slopes are different. So if I tell you that I picked the line with a slope of 1/3, you know exactly what line I'm talking about because there's only one line with a slope of 1/3. However, there's a problem when we run into something like this. Let's say I gave you this picture and I told you to do the same thing and you say, I picked the line with a slope of 1/3. Which line are you talking about?
Yellow.
No, I picked one line. I didn't pick all 3 of them. Which one did I pick?
Whichever one you pick.
Yeah. You don't know, do you? This is an ambiguous case. So the slope isn't really useful here to define the line, or at least the slope by itself. Raven, can you say what you just said again?
Just gotta use an L point.
Yeah. So in addition to the slope, if I gave you a point, and it really could be any point, we're going to talk about which points might be more useful, but if I gave you any other point, let's say the point 3, 4, now which line am I talking about? The blue one, because the point 3, 4 is on the blue line. Okay? So if I give you the slope and a point, that's enough. In fact, there are no other lines, not just among these, but among all the lines, there are no other lines that have a slope of 1/3 and go through the point 4, 3, or 3, 4. Sorry. All right, so the slope by itself isn't good enough there. All right, so back to this question about defining lines. How much information do we need to define a line? To say, that's the line I picked, and I know that's the one, among maybe the lines that are here or among all lines. In Euclidean geometry, without the coordinate plane, what did we need? We talked about this before. What defined a line? How much information? To what?
2 things.
To what kind of things? Chairs?
Points.
Dots.
2 points. Yeah. So if I were to give you 2 points, then you would be able to say, okay, I know which line you're talking about. And among these lines up here, it's pretty easy. It's the bold line there. But are there any other lines that you could possibly draw that goes through both of those points?
Nope.
Yeah, not a line. You could draw a curve that goes through them. So you could draw something like this, but is that a line? No. So that doesn't count. So in Euclidean geometry, what we needed was 2 points. The same thing is true in analytic geometry. In fact, this is no different in analytic geometry. If I throw a coordinate plane on that same picture, it doesn't change anything. Those 2 points still determine the same line. The only difference is now we know the location of those points. One of them's at 0, 1, the other one's at 3, -1, and we also know the slope of the line. We know it has a slope of -2/3. So defining the line is no different. We can define it with 2 points, but we also know a little bit more information now. We know some locations and a slope. Okay? However, in analytic geometry, there's another way to define a line. Oh, that's not where I was going with that. We already talked about that. So if I gave you those 2 points in analytic geometry, that would define that line and that line alone. No other line would go through those 2 points. Now, let's say I wanted to define this line by using the slope. This is going back to kind of what we did in the opener. What's the slope of that dark line, the line that I'm talking about here? The green one. As opposed to the other green ones.
Two negative thirds.
What is it, Austin? -2/3. Good job. So the slope of that line is -2/3. Would it be enough for me to say I'm picking the line with a slope of -2/3? Why not? Yeah, there's more than just that line that has a slope of -2/3. In fact, among the lines that were up there, there's 2 other lines. There are 2 other lines that have a slope of -2/3, so that's not enough. Could I just say I'm picking the line that goes to the point 0, 1? No, that's not enough because there are multiple lines going through the point 0, 1. In fact, there's 2 more there. And I could draw as many as I wanted. I could draw more lines that go through that point, and I could just keep doing this all day. You want me to just keep going?
Yeah.
Okay, take a nap while I do this. I'll let you know when I'm done. Okay, I'm just kidding. So it's not enough to just say it goes through that point. It's not enough to just say that it has a certain slope. But what if we combine those? What if I were to say it has a slope of 2/3? Then which lines are we talking about? Those 3 lines that I had up there earlier, right? I'm just talking about those 3. Now, if I'm just looking at those lines, the slopes of -2/3, and I add in this point. So I'm saying the line that has a slope of -2/3 and goes to the point 0, 1, now which line am I talking about? Just that one. Is there any other possible line that I could draw that has the same slope and goes through that point? No. That's it. It would be the same line, right? As Dante said, it would just go on top of that one and it turns into the same thing. So it's enough to say we know a point and a slope to figure out what the line looks like. So we can define it by 2 points, or we could define it by a point and a slope. All right, so let's talk about how we're going to use this. There are particular points that are more useful than others. And those points are called intercepts. There are 2 different kinds of intercepts. Anybody remember what they are? I'll give you... What did you say, William?
X and Y.
An x-intercept and a y-intercept. What is an x-intercept? It's where a line crosses the x-axis. What's the y-intercept? Where it crosses the y-axis. The y-intercept is the one that we're going to use the most often. It's important that you know what it means to be an x-intercept. Actually, in this picture, we can only see the x-intercept for one of the lines. Which line can we see the x-intercept for? The yellow one. The green one has an x-intercept, but it's over off the graph. And the blue one, the same thing. It has an x-intercept, but it's over off the graph. But all 3 of them have a y-intercept that we can see in the picture here. And the y-intercept is a point. It's the point where it crosses the y-axis. So if we know the slope and the y-intercept, that's exactly what we just said we needed to define a line. We know a point, we know a slope, and that defines a line. So what is the y-intercept? What is the point where the blue line crosses the y-axis? 0, 3, right? So those are the y-intercepts here. So the blue line has a y-intercept of 0, 3. The yellow line has a y-intercept of 0, negative 1. And the green line has a y-intercept of 0, negative 3, right? So those are the y-intercepts. What do you notice about all three of those points? The x-coordinate is 0 for all three of them. In fact, any y-intercept is going to have an x-coordinate of 0. And the reason is the y-axis is exactly where x equals 0. So if it's crossing the y-axis, the x-coordinate has to be 0. Since the x-coordinate is always 0 and we're talking about the y-intercept, we don't need those zeros in there. In fact, we don't even need the ordered pair. We can just say the number. So instead of saying that the y-intercept of the blue line is 0, 3, we can just say the y-intercept is 3. And we're going to use the letter B. It's kind of like the letter M. It's just the letter that mathematicians chose to represent, in this case, the y-intercept, like they chose M to represent the slope. So we're going to say B equals 3. What does B equal for the yellow line? Negative 1. What does B equal for the green line? It's pretty straightforward, right? Any questions about what an intercept is? I hope so. Okay, so you finally get to write something down here. This is the slope-intercept form of an equation. This is the equation that we're going to use to represent a line. There are 4 variables in this equation. What are they? Let's start with the ones we've been talking about. We haven't really been talking about y and x yet. I mean, we kind of have been, but more specifically, we've been talking about what m is. What does m stand for? Slope. So m is the slope of the line. So when we write an equation of the line, we're gonna say m is the slope, and we'll put it in where the m is there. Notice that m is being multiplied by x. The slope is always being multiplied by x in this equation. And then what does b stand for? The y-intercept. So b is the y-intercept. It's not the x-intercept, so don't ever put the y-intercept on the x-axis unless it's 0. Then it would be on the x-axis. But otherwise, the y-intercept should be on the y-axis. Pretty easy, right? So as long as you know which one the y-axis is, you shouldn't have any trouble with that. So how about that x and y? What do x and y represent? What did you say, Maya? Those are coordinates. So the x and the y are just an ordered pair. In fact, the x and the y in this equation are infinitely many ordered pairs that are all in a straight line. Kind of a crazy idea. So that x and y, I can put in a different value of x and get a different value of y every time I put in a different value of x, but I'm always going to get an ordered pair that's on the line. And I can pick any number I want for x, and I'm going to get a different number for y, and it's going to give me a point that's on the line. A line is really just a string of points, strung together. So what I mean by that is if we have a line like that, there are infinitely many points on that line. And we can make them as close or as far from each other as we want. And those x, y's in that equation are going to give us those points. We'll come back to that. Okay. Man, I feel like I asked this question already. I know I did, actually. How much information do we need to define a line? What were the 2 ways that we could define a line? Austin? 2 points. So 2 points is something we did way back last semester in Euclidean geometry, and now we can do it again in analytic geometry. So we can define a line with 2 points. What was the more recent way to define a line now that we have analytic geometry, now that we have a coordinate plane? A point and a slope. So looking at this line right here, if we want to write the equation of this line in slope-intercept form, y equals mx plus b, we need to know 2 things, a point and a slope. B is going to be our point, m is going to be our slope. So what is, let's start with slope here. I just started to ask the question, I gave you the answer. What's the slope of this line? Negative 2/3. What's the y-intercept of this line? What does b equal?
1.
Yep. So b is 1. It's going through the point 0, 1. So if we want to write the equation of this line, what should I put where m is right here? Negative 2/3. What should I put where b is here? 1. And we're going to get an equation that looks like that. So that equation represents that line. Now the reason that equation represents that line, and I promised you I'd come back to this, if I put in, for example, the number, let's say the number 3. Let's say I put 3 in for x right here. Then what I'm going to get is a y value of negative 1. So I get the point 3, negative 1. And I get this point right here. Now, that's kind of a straightforward one. But what if I put in a number like 2.9? Just a number a little bit less than 3. What do you think I would get for y? I'll give you a hint. It's going to be right there. Okay, so I'm not really sure what it is. I know it's going to be a little bit less than negative 1. Probably like negative 0.9-ish something. So we're going to get a number that's going to be right next to it. And I can put in all kinds of x values, and they're going to give me y values that are going to give me all of the points that make this line. Okay, so I can put in any number I want for x, and it's going to give me a y that gives an ordered pair on that line. And that's why we have an equation for the line. So when we want to write the equation of the line, there's two things we need to know. We need to know the slope, and we need to know the y-intercept. So these are the steps that we'll take. We'll find the slope. We'll find the y-intercept. Really, step 1 and step 2 are interchangeable. You can do either one of those first, sometimes. Sometimes you can't. And then we'll plug those two things into the equation y equals mx plus b to get the equation. So I want to take the equation. This is going the other way now. I want to take the equation and see what the line looks like. So what we're going to do for both of these, we'll do the first one together here, is figure out what the slope is, figure out what the y-intercept is, and then graph it. So what is the slope given by this equation? Remember, the slope is a number that's being multiplied by x. So what's the number being multiplied by x here? 2. And what's the y-intercept? That's going to be the number that's by itself, so that's going to be 1. Now, before I even move over to the graph, there's something I'm going to do with the slope. The slope equation, I'm air quoting equation here because it's not really an equation, but slope is rise over run. We always want slope to be a fraction when we're graphing it. So what can I do with the 2 to make it a rise over run? Put it over 1. So our slope is going to be 2 over 1. That gives us a rise of 2 and a run of 1. However, we don't know where to rise and run from unless we do what first? Plot the point. So where is b equals 1? It's Maya, you could be pointing to any point up there, but I think that's where you're going, right? Okay. So this right here is going to be our y-intercept, so we should put a point there. And then our rise over run is 2 over 1, so which way should I go? Up 2 and right 1. Again, you don't have to plot any more points. 2 points is enough to determine a line. However, once you do plot the points, you want to make sure you draw a line that goes through other points that would be on that line. So what I mean by that is, when you draw your line, notice that it also goes through that lattice point right there, and it also goes through that lattice point right there. Why should it go through those two lattice points? Because if we were to... if we were to plot more points using the slope, we would get a point there and we would get a point there. Right, Jake? Also, I want you to be sure that you indicate that line goes on forever by drawing arrows there. So, above each of your graphs on example 41.1, I want you to write the equation. below the graph, I want you to write what the slope and the y-intercept are, and then I want you to graph the line. Notice that you have 3 coordinate planes there. So you get to use a different coordinate plane for each of your lines. I'm going to put all 3 of them on the same one, but I want you to keep them separate. Yeah. So on the yellow line here, what's our slope going to be? It is going to be -1. And first of all, how do you know it's -1, Maya? Yeah, if there's no number in front of the variable, if it doesn't have a coefficient, then the coefficient is 1, or in this case, -1. And since we want to rise and a run, what should I put under the -1? 1, okay. And what's the y-intercept going to be here? -2. What should I do first, the y-intercept or the slope? Does it matter?
Yes.
Yes. We don't know where the slope goes until we have a starting point, so we'll do the -2 here. Where is that -2 going to go? 0, -2 right there. And then down 1 and right 1, and we get another point right there. Again, a poor math student might draw a line that looks like that. It is going through the points that I drew, but it is not an accurately drawn line. We should be drawing a line here that has a slope of -1 over 1 everywhere. So something like this. So if I start at any point on this line, say right here, I could go down 1 over 1, down 1 over 1, down 1 over 1, and keep doing it until I get to the points that we had. Okay? Any questions about that one? All right. This last one here is a problem that a lot of students have trouble with. There's a few different ways to kind of think about what's going on here. First of all, if you think about y equals 4, where does y equal 4 in this picture? Let's think about the y-axis. Where is 4 on the y-axis? It's going to be up 4, right? So this right here is going to be a point on the line. Now, that tells me that the y-intercept is going to be 4, right? Now, let's look at it a different way. I know that 4 is either the slope or the y-intercept. So let's say I'm having trouble thinking about whether I should put the 4 here or the 4 here. Remember that the slope is always the number that's being multiplied by x. Is there anything being multiplied by x here? No. This is the same thing as saying y equals 0x plus 4. Okay? I think that's a good way to think about it. If there's no x in there and you need to add it in so you know what the slope is, you can add it in. It's just got to be 0x. So we're really just adding 0 to the equation. If you had the slope but you don't have the y-intercept, you could just add a 0 to the end and you have a y-intercept of 0. Either way, what's the slope going to be? Slope? 0. I'm not going to put 0 over 1 because I know it's going to be what kind of line? It's going to be a horizontal line. And then the y-intercept is going to be 4. So let's go ahead and just draw our horizontal line through there. And we get something like that. Okay, we've got 4 more examples to do in 12 minutes. We're going to have to kind of rush here a little bit. All right, so keep up. We're going to do 4 more examples. These 2 lines are supposed to be in this here. All right, so the next 4 examples, we're going to use those steps that you just wrote down. Step 1, find the slope. Step 2, find the y-intercept. Step 3, plug it into y equals mx plus b. So I'm going to give you a little bit of information. I'm either going to give you 2 points, or I'm going to give you a point and a slope, and you're going to tell me what the equation of the line is. All right, so the first one, we want the equation of the line going through the point 0,5 with a slope of 2/3. Now, this particular problem is about as easy as it gets. Who can tell me why? What did you say, Ade? Okay, because x is 0. What does that mean? Ade says that x is 0, and that's useful here. That's not what I'm... Why is it useful that x is 0 in that point? Because that point is that is the y-intercept. So this point right here tells me that b equals what? 5. Now, step 1 says find the slope. Well, guess where the slope is? It's right here. Step 2 says find b. Guess what b is? It's right there. So we get to go straight to step 3 and plug everything in. When we write the equation on the line, y and x will stay in there. So it's always going to be y equals something. So it's y equals what? 2/3 x plus 5. Now, I need to make a few comments about how we're going to write these equations before we move on. We do get the equation y equals 2/3 x plus 5. There are two ways that you might accidentally write this, and I'm going to say it's accidental because I know you wouldn't do something wrong on purpose. That would be wrong. That would be wrong. And any variation, something that looks like that, and I'll come back to it. Or this would be wrong. And when I say wrong, I really mean ambiguous. And ambiguous is just as good as being wrong. Because if we don't know what it means, then what's the point? Okay, what's the problem with this one? Tiffany? Okay, good. What we want here is the slope times x. And what it looks like here, I don't know if the x is really under the fraction or not. So it looks like 3 is being multiplied by x. And we don't want that. We want 2/3 to be multiplied by x. So this is not good. One thing you can do that's kind of related to this is to write it like this. You are allowed to put the x on top. Now, Dante just said something that is useful here. If you put parentheses there, there's not going to be any confusion. Even though the x is down low and it just doesn't look good, that would be okay because there's nothing above the x to say that it is in the denominator of a fraction. So parentheses would be okay here. It's also okay to write x in the numerator, but it's not okay to write it in the denominator. Typically, though, you'll want to write it off to the side like we have it here. If you just write it off to the side of the fraction bar, you'll be safe. The other issue you might have is this one right here. Now, I know some of you like to write fractions like this, side to side instead of top to bottom. I'm not going to hold that against you. Even though I don't like it, it's okay. But what's the problem with this? Again, it looks like the x is in the bottom of that fraction with the 3. And that's not what we want. So if you write your fractions like this, how do you need to make sure that it doesn't look like that? Put it in parentheses. So it's really the same fix there. Okay? Any questions about that? Okay, moving on. We have 3 more examples, and they're going to get more difficult, so let's go quickly. Step 1 says to find the slope, right? Cool, we're done with that. Step 2 says find the y-intercept. We are not done with that. Anybody remember from what you learned last year how to find the y-intercept when we know the slope and we know a point that is not the y-intercept? Yes, Maya is exactly right. We're going to plug it into this equation, y equals mx plus b. And since there are 4 variables in that equation, if we want to solve for one of them, we need to plug in 3 of the others. So what 3 things can I plug into that equation? Okay, I can put the slope in for m. I can put the x in for x, and I can put the y in for y. So when I do that, what do I get? 1 equals -3 halves times -4. Why did I put both of those in parentheses? Yeah, those negatives, especially that 4, if you don't put parentheses around it, it just looks like -3 halves minus 4 instead of times -4. The parentheses around the -3 halves aren't absolutely necessary, but around the -4 they are. 2 things are going to cancel in that expression. -3 halves times -4. The fraction, or the negatives are going to cancel. Negative times a negative is positive. And the 2 and the 4. The 4 is in the numerator. The 2 is going to cancel and become a 1. The 4 is going to cancel and become a 2. And what do we end up with? 6. So we have 1 equals 6 plus b. And then to get b by itself, subtract 6 and we get negative 5 equals b. How about negative 5 equals 5? No? B. Yes. Okay. Now we can write the equation of the line, right? What is the equation? Y equals negative 3 halves x. Yep. You could say plus negative 5. I don't really like that, but it's not wrong. It's much simpler to just say minus 5. And really subtraction is adding a negative. So that would be okay if you wanted to do that. Any questions about that one? Okay, next one. We need to find the slope and the y-intercept. I know what one of them is already. Partly because I've done this problem before, partly because what? You guys should know it too. Yes. This point right here is the y-intercept. So, I know what the y-intercept is. Well, what is the y-intercept? What's b? It is negative 1. So the y-intercept is negative 1. We'll say b equals negative 1. So how do I find the slope? Plug it into what? What equation? Nope. There's an easier way. Yep. You guys remember the slope formula? Why? Alright, so in this case, what is y2? What's y1? Right? Okay, and x2? x1? Negative 1 minus negative 3? Positive 2. 0 minus negative 1? 1. So the slope is 2 over 1. Now there's two different ways you could write this equation that would be acceptable. The first...
Excuse this interruption for a quick sporting announcement. The freshman...
The first... He actually does that on the phone, but okay. So you could say 2 over 1x minus 1, right? Actually, there's a bunch of different ways you could do it. I can think of 4. Or you could just say 2x minus 1. I don't know why I wrote a 5 there. I'm having trouble today. So we get that equation right there. Any questions about that one? Okay, we've got one more. We can do this. The problem with this one, though, is we don't know the y-intercept or the slope. Which one should we do first? Or does it matter? It does matter. We actually can't find the y-intercept until we know the slope. So we need to find the slope first. We just had the slope equation. What is y2 minus y1? 4 minus 5. x2 minus x1 is 2 minus 4. 4 minus 5 is? 2 minus 4 is? So we get negative 1 negative halves. Or we could just say 1 half. That would be much more appropriate. So there's your slope. Now that we know the slope, we can pick one of these 2 points. Does it matter which one? No, it doesn't matter which one. I usually go smaller numbers compared to bigger numbers. I usually go positives compared to negatives. I like zeros compared to anything else. In this case, 2, 4 is smaller than 4, 5, so that's what I'm going to use. So y is 4 equals the slope times x is 2 plus b. What's 1 half of 2?
1.
So 4 equals 1 plus b, and so b equals 3. So now we know the slope and the y-intercept. So we get y equals 1 half x plus 3. Yay, we did it.